The title of this submission is Technology Adoption and E-Learning in Architectural Education During COVID-19. My name is Professor Adam Fingrut from, CUHK School of Architecture, and my research partner is Dr. Hilary from the Center for Learning Enhancement and Research. There is a persistent need across different disciplines to incorporate new technological processes in teaching and learning programs to address the increasing complexities of professional practice. 2020 saw COVID-19 change education globally, canceling face-to-face learning and turning toward online education platforms. The impact of this is heavily felt in studio-based subjects, such as architecture, where the risks of working exclusively within the digital environment can create an illusion of rigor, which obscures the role of active critical assessment. In the architectural discipline, digital scanning, computational design, and robotic fabrication are emerging as new teaching opportunities, particularly with the necessity to incorporate remote and e-learning due to COVID-19. This presentation discusses how emerging technology in the classroom is integral in the cultivation of design thinking. It exposes participants to a process of discovery learning. Tools are introduced to students to stimulate an iterative design and problem-solving approach where a cycle of action, observation, reflection, and reaction can occur. Exposure to these methods prepares students for their future careers in an increasingly technology-driven world. The research is interested in problem-based learning, technology as a conduit for discovery learning, developing an aptitude toward evidence-based iterative knowledge gain, breaking down fears of technology adoption, how to define a problem and target solutions, and the cultivation of graduates with an aptitude toward technology and a positive association with curiosity. Long before COVID, the intention was to introduce robotics as part of the discovery learning experience. But changes in the curriculum needed to be made in order to accommodate social distancing regulations. A summer elective course was set up to expose students to an iterative approach to design problem solving with mostly independent investigations into technology and drawing tools they wish to use, and collective meetings and conversations. Its main objectives were to gain experience presenting design problems and solutions, adopt an iterative and practice-based approach toward design problem solving, develop an aptitude for exploring digital tools and applications, produce original design output based on concepts explored throughout the curriculum, and an understanding of the relationship between design decisions and production complexity. This set the stage for a more serious teaching endeavor of a graduate level studio, a 2-term, 24-credit core of architectural education. The studio calendar is broken into 4 main areas: a warm-up phase where students primarily focus on drawing and making, a body phase where, with knowledge and experience gained from previous exercises, students conduct rigorous study of the ergonomics and the body. A phase called the gathering, again, with knowledge and experiences gained from previous exercises, students join into groups to develop full-scale project, architectural intervention. And then they go to an even larger project called the collective, where they develop their previous work into a series of buildings and civic infrastructure ranging in scale and complexity. At the current moment, we're around here in the calendar, as this is an ongoing project. The main principles behind the course were these 3 words: scan, design, and build, which can be translated clearly into observe, experiment, and make. The course and methodology basically bifurcates the students into 2 different ideas. One about technical development, where they look at new tools, new workflows, troubleshooting, and finding resources. And the other is the development of their design identity through declarations of interest, peer criticism, compositional strategies, and the development of a subjective argument. The research is also very interested in problem-based learning because it's iterative, it's practice-based, it's critical in its exploration, it's focused on knowledge gained through previous iterations, it's about application of that knowledge gain, and it's about reflective learning. In terms of online communication methods, the first one we really adopted was the Blackboard because it serves as a great platform for blogs and data collection. Of course, more informally, WhatsApp and Zoom presentations. And a third one was Mural, which is a virtual pinup. In traditional architecture, we would have hand drawings or work printed out and then pinned on a wall, and this allows us to do it. And all users that are logged in can zoom closer to review work. Here you see a student hand drawing. At the beginning of a course, a questionnaire is passed out. Questions like, what is your main objective when using digital technology? How do you approach learning those tools? Were they taught in formal workshops or classes or alternative methods? How do you feel when approaching a new tool? Do you use technology as part of your design exploration, or is it more of an output device? Are the tools you use for school the same as what you expect from professional practice? How satisfied are you with your current tool set? The future of technology integration will be an ongoing part of your professional practice, agree or disagree? And the overall impressions from the first survey basically stated that students aren't clear on their professional practice requirements. They don't have positive experiences using technology as an explorative tool. They all know that technology is a fact of life for their future. They're not satisfied with their current digital footprint. They already rely exclusively on the internet for information and learning technology, and they associate digital tools and computation with difficult learning experiences. Now I'm going to introduce the course in terms of scan, design, build. Scanning traditionally can include methods like hand drawing and draw what you see, but more contemporary ways such as photogrammetry and 3D scanning can start to be incorporated. We included in this course a photogrammetry workshop that allows you to capture with a handheld camera like your mobile phone and digitize that into three-dimensional geometry. We also obtained a courseware development grant for 6 units that can be deployed into student homes for developing 3D geometry and models from home, along with all the software. This allows more traditional methods like a self-portrait or a hand drawing to be mixed with more contemporary technology like 3D scanning to be studied in 2 different ways. I'm going to show one example of student output. It's a 1-week assignment given at week 10 out of 13. It incorporates very nicely this concept of scan, design, build. It's a simple and open design and build problem, and it's conducted entirely by remote learning. The task was, with knowledge and skills gained through previous research into the body, the assignment asked you to introduce a very simplified program to help drive a design problem, to develop and create a device for eating. So they need to quickly develop and decide on what kind of food item they are going to serve or eat, and how they're going to use data in terms of the body and the ergonomics to develop and create a design for a plate or something like this. One of the groups was interested in a pineapple, for example, and here you see how accurate a 3D scan of the pineapple could be. Another group was interested in a prawn, and they adopted a few different techniques for scanning. One is the photogrammetry method. Another was straight form analysis using impressions and materials. And here is also a 3D scan. In terms of the design phase, it's really used as an opportunity to explore new workflows for students to invent on their own an original workflow or design method. And then they can apply it to the material at hand. It allows them to abstract the work that the observations that they've gained from the material world and start to turn it into a diagram format that they can then use as a substrate for more explorations and activities. There's a wealth of information that they gain through this process. Here you can see how they can analyze that material. Another one about measuring in a very, very rigorous way. From this point on, they're able to connect their own activities and introduce some of the programmatic components. Now, all of this is happening remotely, I should add, because they've been given the tools necessary to do it without coming into the fabrication facilities of the school. here. Here you can see how they're organized in their conventional tool setup. And again, how they can use some of the scanning technology, for example, to incorporate that into their design ideas, and how they can begin to test fabrication methods. Along with the power of computational tools, they can quickly develop digital prototypes and establish the best conditions based on the overall information and variables they're working with. Here you can see a study of a digitally scanned hand being tested against a computationally driven design model for holding one of their food items. Traditionally, in the build phase, we would use larger prototyping and fabrication equipment. So students can develop complicated models, spaces, etc. But of course, this wasn't available. However, 3D printing costs have come down significantly so that some students can either print from home or send out their files for quick turnaround and delivery. Here you see some of these rapid prototypes as part of their final output. Brought together with their interest in material, they can continue to perform analysis on what they've created. And here you start to see some primitive tools that are being incorporated into the design. Again, this project even performs analysis on their own cutting methods with rigorous observation, rescanning, measuring, again, all of the materials, categorizing, simplifying, and developing their own templates for cutting the material, both from raw as a pineapple or into the specific layout on the design plate. As well, here you're seeing another fabrication method where students sent out some of their material to be cut. An important part of this course is about material and design failures, which are encouraged to be highlighted as seen as opportunities to add knowledge in further iterations of the work. Again, what you're looking at is 1 week's worth of work. So further reflection is also really important on how the students will refine their work into later iterations. A second questionnaire is always given, asking questions like, what tools have you selected? What way have you explored those new tools? How will you reflect further on this course and the process? How will these new tools impact your future design work? How difficult has this experience been? Overall impressions were that students had a wide variety of interests in technology exploration. Tools can be combined to produce more complex and customizable results. They realize the enormous opportunity technology exploration can provide for a variety of design. They've gained confidence in something they otherwise avoided, and they accept the difficulty level and are still willing to explore new technologies. What's next? 14 VR headsets have been secured along with the specific software that links the equipment to the 3D environment for a more immersive experience. This is really to enhance the design phase of things. While we have well developed the scan and build, that creates more opportunities for design. In this case, how we abstract and communicate with each other and how we can critically assess that information. So now we have this possibility of digitizing and also output of analog simultaneously at any moment through remote learning. Thank you.